Alright, so welcome to this segment of my calculus in AddMath. So I want to start with important. I want to start by highlighting some important derivatives that you need to remember. So some important derivatives you still remember. If you have y is equal to ax raised to the power n, we did say that dy over dx will be equal to, you multiply the exponent by the number in front, so that is an, then the exponent reduces by 1. So therefore, as my first one, I can say if you're finding the derivative of ax raised to the power, well, let me just say, x raised to the power n, if you're finding the derivative, it simply means it will give you nx, this times that, then n minus 1. The second one that you need to remember, if you're finding the derivative of sine x, the derivative of sine gives us a cos x. So that is what you need to remember. Then if you're finding the derivative of cos of x, it will give you negative of sine x. So these are things you need to remember. Then if you're finding the derivative of tan x, this is going to give you sec squared x. You can actually prove all these. I'll show you in my other video where I'm going to prove some of these. Yeah, you can also find the derivative of what we are calling as being sec x. So the derivative of sec x will give you sec x, then tan x, where the x are obviously angles, and in most cases when you talk about the angles x, we normally are given in radians. You remember in radians how to do the conversion if you want. Remember 2 pi in radians is equal to 360 degrees. It simply means that pi in radians is equal to 180 degrees, which simply means if you do half of that, pi over 2, that should give you a 90 degrees. So you can go on and so on. Then the other one that I can tell you is that the derivative of cot of x. So if you are finding the derivative, it is negative cosec, negative of cosec squared x. The other one that I can talk about that is important is that the derivative of in this case cosec x is equal to cosec x then cot x. These are important ones that you need to remember. Let me not leave it. Of course, as you look at maybe natural logarithms, you are going to be using that. If you are finding the derivative of an exponential function e to the power x, it will always give you back the same. It's a special type of a function which will give you e to the raised to the power x. Let me conclude with the ninth one. If you're finding the derivative of log of x, meaning it has got a base of 10 there, this, when you find the derivative, it will give you 1 over x. So these are just important derivatives. I'm not saying these are the only ones. There are a lot that you have, but these are some of the derivatives that you need to remember, especially one up to, let me say, up to 5 more especially are going to be common. 8, you need to remember also that one. So very important. Let's try to show you how you can apply some of those coupled with what we did look at as being using a composite function, the chain rule. Either you're dealing with the chain rule, the quotient rule, or what we called as being the product rule. So this is what we are going to look at. So if you see the problems, if this is the solutions, it says find the derivative of each of the following. So now if you look at the first one there, it says y is equal to x raised to the power 3 and sine x, and I want you to find the derivative. So in this case, this is actually treated as you can use the product rule, where it's like you have, this is your u and that is your v. It's like you're multiplying the two expressions that you have. So you can use what we are calling as being the product. So here when you find it like that, you can use the product rule. it's like you're multiplying in this case. So in this case, I'm simply saying that my u is represented by x raised to the power 3, and my v is equal to sine, x. That's what we mean. Now, the derivative, if you remember from the first principle, when you say u, you put up a complement there, it simply means the derivative. In other words, u complement, it's like I'm saying, it's like I'm telling you to say it is du over dx. So what is du over dx? It is going to give you 3x raised to the power 2. I'm not going to be using much of that. I may be using that. You'll be seeing that. Then v complement, that's the dv over dx. Remember, when you differentiate, sine, that is going to give you, in this case, cos x. So that is what it is going to give you. Now for the product rule, if you remember dy over dx, if you're using the product, it simply means it is going to be, if you remember the product, it will be u, then you find the derivative of v plus v, you find the derivative of u. That's what it simply means. Please, this is the same as you writing it. I know, in case you are familiar with that, you simply say u dv over dx plus v, then du over dx. That's what we mean there. It's the same, even if you write it like that. This is just the simple way, but that's the way you can do it there. All right, so dy, in this case, dy over dx will be equal to, what is your u? Your u is x raised to the power 3. And what is the derivative of v? Remember, we got that one as being cos x, plus what is my v? My v is simply sine x. And what is the derivative of u? It is 3x raised to the power 2. So you just expand and try to see if you can factorize, simplify it in its form. This times that will give us x raised to the power 3 cos x, plus this times that will give us 3x squared, and that is going to be sine x. I think if you see what is common, x squared is common. I can move out x squared is common. Here when I divide x squared, I'll remain with x cos x, plus there when I divide x, I'll remain with 3, sine x. So this is actually our dy over dx that they wanted you to get. So when you find it like that, you simply treat it as a product rule. It's like you're multiplying, so use the product rule to do that. All right, let's look at the b part and see, how we can go about, that. So let's look at the b part. So if you look at the b part there, if you look at the b part that we're having there, so the b part there says, y is equal to cos x over x to the power 2. So if you notice here, it's like you have, this is your u and that is your v. It's like you're dividing. It's like you have y is equal to u over v. So if you're dividing, it simply means you need to use what we call as being the quotient rule when you find an expression is being divided. So therefore, I'm going to say my u is equal to cos x, and remember the derivative of cos x is going to give you negative of sine x. Remember that. And my v is equal to x squared, so the derivative of that will give me 2x. That is what you need to remember. Now, of course, how do I get dy over dx? Using the quotient rule. So according to the quotient rule, you start with your v. Of course, other books will tell you different one, but start please with the v. So it's v, then you find the derivative of u minus, in this case, u, then you find the derivatives of v over v squared. So that is what we call the quotient rule. This is the same as you're writing it, dy over dx is equal to v du over dx minus u, then dv over dx, then whatever you get over v squared. So don't be confused, this and that. It's just the same expression, that you're having there. So let's try to see if we can actually work out that. It will be dy over dx will be equal to, what is my v? My v is simply, x squared. And what is the derivative of u? It is negative sine x there. Okay, minus my u is simply cos x. And what is the derivative of v? it is simply 2x, and whatever we get, it is going to be v squared, which in this case is x squared, but again raised to the power 2. We can expand to give me negative x squared sine x, then minus this times that will give me 2x cos x over, if you notice there, this times that will give you x raised to the power 4. So what can we do? We can simply, if we want, actually, factorize that. What is common? X is common, and negative, so negative x. If I'll remain with x sine x, there it will become positive, and I'll remain with 2 cos x over, x raised to the power 4. So this is my dy over dx. The idea is that you want to simplify it to its simplest form. So that's the idea, and that's the way you can actually go about it. So basically you can do that. Let's try to see if we can do the last one. If you are able to appreciate that, are we going to use the product rule, or are we going to use the quotient rule? If you look at the C part there, okay, you're right. If you say it, it appears as if it is actually a product. So it is sine x, and that is cos x. It's like I've got my u and I've got my v there. It's like you're multiplying y is equal to uv. It's like you're multiplying them. So you can use the quotient, the product rule. So u is equal to sine x, and my v is equal to cos x. Remember, the derivative of that will give us, in this case, cos x, and the derivative of cos will give us, in this case, negative sine x. So that is what you need to remember. So since it's the product, it means dy over dx will be equal to u, the derivative of v, plus v, the derivative of u. So what is my u? It is actually sine x, and the derivative of v, negative sine x, plus what is my v? It is simply cos x, and what is the derivative of u? It is simply cos x. So if you notice, this times that will give us negative sine squared x, because you are multiplying, so it becomes squared, plus this times that will give you cos squared x. Now, of course, if you look at such an expression there that we're having there, we can factor out -1, and when I factor out -1, I'll remain with sine squared x. That is what we are going to have there. 1 is actually common, and if I try to look at this one, it will be minus cos squared x. But of course, if you look at this one, there are higher identities that you are going to find that are going to be having this later on. In fact, let me just say, if you just try to change this one, where it says cos x squared minus sine x squared,